Okay, well, welcome back. We're going to talk about some totally tubular integration, man. Like, totally gnarly, dude. Yeah, that's my crush thing whenever I teach about totally tubular integration, or should I say tabular, dude? Um, that's what I usually say because I just think of Crush from Finding Nemo when I do this. Um, yeah, tabular integration is actually what is called tabular. And what that means is we're using a table to integrate. Now, why would you use a table when you're using parts? Well, when you see this, we see two functions being multiplied. And normally we pick parts to help us figure this out because we can't use substitution or anything like that. Now, we use a table, unlike if you watch my other videos, unlike the Magic 7, because sometimes when you do it, you have to do this more than once. And just to illustrate that, I'm going to go through this example of what happens when you use parts for the first time around. All right, so I'm going to use parts. I have my u and my dv. I'm going to do little integrals always taste excellent or light to help us figure out what to pick for u. I'm going to use algebra x to the fourth. And we're going to use the e to the negative x right there. We got our du, which is going to be 4x cubed. And then we're going to have our v, which will be negative e to the negative x. So that's what we got there. Using magic 7, bada bing, bada boom. What we'll have then is negative x to the fourth, e to the negative x, minus the integral of this right here will be negative makes negative makes positive, so I'm going to turn that positive to negative, make that positive. And then we have the 4 on the outside. I'll just put that right there. And then we have x cubed, all right, e to the negative x. All right. And what you realize is that, hey, I have to integrate this. And when I integrate this again, I have to use integration by parts again. So I pick my u and I pick my dv, all right, and all this other cool stuff. And all I have is, all right, x, and that's going to be my x cubed now, and this is going to be e to the negative x, and then I do the same thing over again, and we have 3x squared, and we have negative e to the negative x, and then I do the magic 7 again. I'll put this in a different color. All right, magic 7, and what you realize is that, once again, don't forget the other part, you have negative x to the fourth, e to the negative x. You're going to have plus 4, and now we're taking the integral of this. So we're going to have to take all of this, and we're going to take this times this, which is negative x cubed, e to the negative x. And then what happens is you're going to minus the integral of, once again, the negative makes a positive, and then we have this right here, which is going to turn into, put my 3 right there, and then you have x squared, e to the negative x, and then you realize, oh my goodness, I have to do this again. So then you do it again, and it just keeps on going on and on and on. You have to do it repeated times. Well, whenever you have to, when you realize, or maybe I should help you realize when you know you're going to have to use parts repeated times, is whenever you have here a function, and let me get a little, where can I get my little, there we go, there we go. I'll get a highlight here. Whenever you realize you have a polynomial and a repeating function, all right? You have a polynomial and a repeating function, you're going to use parts over again, okay? And that's where totally tabular integration, dude, totally works. So this is what totally tabular integration is, okay? This is how you can apply it. So let's get my pen here. What we're going to do is, instead of doing this over and over again, we're actually going to just set up a table. And to help us do that, I'm going to actually move this down. So if you come, follow me, follow me. All right, we'll move this down here in my little thing right there. Okay, so what we're going to do is, I have a nice little spot right here. Um, we're going to do our totally tabular integration. So I'm going to get a different color. And we're going to do the same thing. We're going to pick our u, and we're going to make a table. Okay, we're going to make a table. And we're going to pick our dv. Okay, now when we go through here, we're going to pick our u the same way you use light. If you don't remember what that is, light, little integrals always taste excellent. So we're going to pick our x to the fourth. It's going to go right there. And the other one's going to have e to the negative x. Now, what we do next is this side, we're going to take the derivative repeatedly. So we're going to have 4x to the third. This one then is going to turn to 12x squared. We're then going to keep on going until we get 24x. And then we're going to keep on going until we get 24 right there. And then until we can't do anymore and get 0. So we can get 0 right there, and we stop. This side, we're going to take the antiderivative. Remember, we have to find v each time. So we're going to take the antiderivative. So we're going to integrate each side here, right here. So we're going to integrate this side. This way, we're going to differentiate. And so we're going to integrate this side. So we're going to have negative e to the negative x. This one's going to be e to the negative x. It's going to be negative e to the negative x. And you see that it repeats over and over again. And this one, we're going to have e to the negative x. And then we have negative e to the negative x again. Okay. Now, from here, to understand how we're going to take our, all right, u times v. So this is our u. Here's our v, if you recall. So we're going to now take this. We're going to take u times v. All right. So this one, we're going to take u times v. And what we have then is going to be, in this case, negative x to the fourth. All right. E to negative x. We are then going to have to go through, and since we had to use, all right, integration by parts, because now we have negative, all right, negative integral of v times u. So our next one, we're going to have to integrate again, and we're going to have to use, basically have the same setup again. So now we have to take this times this, because once again, you have to remember, this is u times v. But remember, also remember, that we are using, all right, the opposite of this integral. So what we're going to do is we're going to have to set up the opposite. So this one was first positive, because that's our first v times u times v. We then are going to have our opposite, all right, because our opposite of our integral of v times du. Once again, we have to use this again. And if we just keep on going through here, we're going to have to keep on multiplying that. And what's going to happen is that we keep on alternating signs every time we take u times v, all right, in this progress of repeatedly using integration by parts. So we have to make sure we always change the signs or multiply it by positive, multiply by negative, multiply by positive, multiply by opposite, multiply by positive, and so on and so forth. So what happens then is we just multiply these. We take the opposite of the product of our two terms. So this is going to be 4 x cubed e to the negative x. Now we're going to add the negative, so it's going to be another negative here. All right, 12 x squared e to the negative x. And then we're going to have our opposite here, because it's opposite here. We're going to have opposite, all right, 24 x e to the negative x. And then we go the plus here, but we have the opposite already, so we have an opposite. All right, 24 e to the negative x. And that was our last one, because we got the 0 here, and then we're just going to go plus c. And that's what we have. And we can factor out e to the negative x for each one of these, and actually at negative e to the negative x if you wanted to simplify this. All right, if you're a superstar and you can do that. So we go minus 4x cubed minus 12x. Oops, factor out negative, so it'll be plus. All right, squared. We get a plus 24x. Then we get a plus 24. And then we have the plus c. And there we have it. There we go. And you can see, as we went through, that that's what we would have for our other terms. So we have, all right, negative x to e to the negative fourth. We would have, if you just read this through, we had 4, negative 4, x cubed e to the negative third. And we take this 4 times 3, which would be 12. But then once again, you have to remember that we took the integral of this, and so that would make it opposite. All right, and it was actually a plus, but it was opposite because that's when we took the derivative or the antiderivative of the other one. And you can see how this pattern would go unfold. And that's what we call totally tabular integration. All right, we're using a table to help us integrate our values. All right, well, let's try another one. I'll show you another one how we do this. So once again, we're going to use totally tabular integration, dude, because we have an x squared and a cosine of x. Cosine of x is a repeating. You go with cosine, sine, cosine, sine, cosine, sine. We do the derivative or integral in any case. So because we have this polynomial, we have a repeating function. When you take the derivative or integral, we're going to use a table. Let's figure this out. So I'm just going to pick our u. Our u is going to be x squared. I'll just tell you, use always the algebra. All right, always the algebraic function or the power function. For our dv, we're going to pick cosine of x, the thing that's left over. All right, so we're going to take the derivative of our u. So it'll be 2x. It's going to just be 2. We get our 0. Over here, we're going to take the integral of dv, so we can get v. All right, we get v. The integral of cosine is going to be sine. Integral of sine is going to be negative cosine of x. The integral of that is negative sine of x. And now, from here, we can then take this, where it's going to be positive, multiply, and multiply is going to be negative, and multiply over here is going to be positive. So as we got, we're going to have x squared times sine of x. This one, we have a negative opposite. Opposite times the opposite is a positive 2x cosine of x. Right here, it's going to be a negative times a positive, so it's going to be minus 2 sine of x. And we're going to have plus c. And we could probably, I don't think we can simplify this any farther. And there we have it. And that's our tabular integration. All right. So that's tabular integration, or tiddly tabular integration, however you want to say it. Remember, when you have a repeating polynomial and then a trig or an exponential function that repeats, set it up. Remember to multiply u times v, all right, cross, and then change the signs from positive. So it's positive because u times v, then you have the opposite, then positive again, the opposite, and it alternates the sign. All right, for each term. There you go. So I hope that helps you out. Good luck and God bless on the rest of your problems.